Hey guys, I'm here to talk to you guys today about rectifiers. A lot of people had questions about rectifiers. What are they? How are they used in transformer? So I'm here to discuss rectifiers in detail, and I'm going to be going over half wave and full wave rectifiers in this video. So a rectifier is basically useful when we want to convert a AC source, which is usually fed into most of our homes, businesses. Usually we're dealing with an AC signal that needs to be converted into a DC signal for our appliances or other things that need to be used. So the main premise, the first thing that we got to discuss is diodes. And if you don't know what a diode is, you have to go back to the basics and read about diodes. And an easy explanation about what a diode does is that it basically takes a current that is flowing through a wire, because you can think about a current flow like a water flow, and it basically acts like a valve. So if you see this diagram here, this triangle represents the diode. The line shows that it's just a regular ideal or practical diode. It's not a Zener diode, which I'm not going to go over in this video. But you can see that it restricts which way the current can flow. So right here I have a positive or forward based diode if we're talking about a regular alternating AC source that's going to be fed into this wire. And over here I have a negative diode, which is in the opposite direction, or you can call it reverse biased, for a positive half cycle that's going to be flowing through this wire. So now that we've got diodes out of the way, let's discuss a little bit about half wave rectifiers. Now, it's always best to start off with the half wave rectifier, because then it's better, it's useful, it acts like a building block for the full wave rectifier, which is a little bit more confusing, but it's not that bad. So again, an AC signal is comprised of a alternating current or alternating voltage, whatever you want to call it. I'm using voltage in this case, but it's alternating current, which goes from a positive to a negative to a positive to a negative, and it follows a sinusoidal curve, meaning that this curve is similar to a sine curve. In fact, it's very similar, it's the same. And this is the electricity that we want to convert into a DC signal. Now, I'm not going to go into full detail about how a DC signal should look, but a DC signal is usually a flat signal that is fed into most appliances and is used for simple appliances. And most appliances don't run off AC; they have to convert it to DC. So what a half wave rectifier is going to do is it's either going to take the positive portion of the AC signal or the negative portion of the AC signal and only keep that part of the signal. Since the alternating current is alternating back and forth, we can take advantage of either one full half cycle or a full one negative cycle to make sure that we're only feeding either a positive or negative DC-like signal into our appliances. So as you can see, if I want the positives, it's going to be useful for me to use a forward-based diode in my circuit to make sure that I can take advantage of only the positives and eliminate the negatives. So, if you look at here, I either want a positive signal or a negative signal, and diodes help me achieve that. So, if we look over here, here's a diagram of a typical transformer right here. That we have an AC signal being fed into the transformer. There's a coil here, there's induction happening, and there's lots that we got to take care of. But you can see that there's one diode here. That diode is useful to convert the AC signal that is being fed into this circuit and take advantage of only the positive half cycle or the negative half cycle. As you can see, I've drawn the circuit in a simplified way here. there's a load here, or a resistor, there's a diode here, and the whole circuit is connected. You can even add a ground. Here's my alternating current source. It has a certain hertz or frequency, and it has a certain voltage. When the positive half cycle is applied, I'll get a current flowing this way through the load and then back around to my other cycle. But when the other cycle occurs, the negative half cycle, I'll be restricted. So if this is my AC signal, the negative portions will be reduced, and I'll get a curve that looks like this. So why do they call it a half wave cycle? You're only getting half, and then nothing, and then half, and then nothing. So over here, this is going to be your final product. So initially we had a negative here and a negative here. But that's not the case. When we apply the half wave rectifier, this is what we're going to get. So a lot of you probably are asking about, if we're using an ideal or a practical diode, what's the voltage drop and how much should we subtract from our load? Well, we have a voltage VP, which is going to be our peak voltage, is going to be our V source, which is the source voltage, the peak voltage of that, minus, if we're talking about an ideal condition, 0.7 volts. So you're gonna have to subtract that from your voltage diagram. And since we're dealing mostly in volts, the textbook gives a lot of formulas for volts. So the theory behind this is very simple in that case. It gets a little bit more complicated for the full wave rectifier, which I'm going to discuss next. But as you can see, the theory is the most important part, and the formulas are plug and chug. Again, I explained that this one should be self-explanatory. The V peak of your output voltage should be your V source peak minus your 0.7 volts if you're dealing with a practical diode within your circuit. Your average voltage is going to be your VL peak, which you just calculated, divided by pi. Using Ohm's law, we can get the average current flowing through. And your PIV, which is your peak inverse voltage, is usually equal to the source voltage, and that is the voltage that the circuit can handle in the reverse direction. If you apply anything more than that, which is rare, the diode will not function properly. So if you need more help, go look in the textbook. But this is the main premise of a half wave rectifier. I'm going to go over full wave rectifiers in the next video. Hope you learned something.